Okay, so here's our last page of our 1-3 function review. So here we go. Our first question always, are we talking about a function? And yes, we are. Is it continuous? Can I put my pen on it and trace it from start to finish? Guess what? Yes, I can. But is it one-to-one? Oh, no. It fails that vertical line test, so that's a no. Now my domain for this graph starts and stops. So I have -4 as my lowest and +10 as my highest. My range is where I'm again going to look at this output. How high and how low does my graph go? My lowest is going to be an output value of -1, and my highest is an output value of +4. All of these domain and range values are boxed because each of these values is included. All right, here's our ant. Where is it increasing? Our ant is climbing up from this value of -4 all the way up to this value of -1 or of +1, but guess what? It's still going up all the way up to this value of 5. Remember, your interval is always using parentheses, and your interval is always an x conversation. So my ant is walking uphill from -4, from an x value of -4 to an x value of +5. Now is when my ant starts to decrease. He's walking downhill now. So as he's walking downhill from +5 up to +10 is when my output is decreasing. All right, where is he constant? There is no interval. What interval is he constant at? None. He's always changing. He's going up, he's going up, he's going down. My x-intercepts are going to be here where it crosses my x-axis. So that looks like over -1 and up 0. My y-intercept is going to be over 0, up 1. The absolute maximum, that's going to be the absolute maximum of my graph, is going to be right here at my highest point. Over 5, up 4. At over 5, up 4. This absolute maximum is going to be, I get as high as 4. That's my absolute maximum. And notice that's my top of my range. My absolute minimum, you guessed it, is going to be the bottom of my range. So when I go over to this ordered pair here, that's at over -4 and down 1. So over -4 and down 1. And guess what? This here is the value of my absolute minimum. All right. Let's take a look at number 27. Answer the following questions about the relation. Is it a function? If it is a function, we need to make sure there's no repeats. So -3, 1, 1, 3, and 5. Is it a function? Yes, because I don't see any repeats in my domain. Here's my domain here. All right, so it says, what is our domain? Because these are isolated points, we can say our domain values are -3, -1, +1, 3, and 5. The official formal way of listing these is in Set Builder. So all the values of x such that x is equal to, and we can make them into a set. All right, when we're talking about the range, our output values are 0, -2, 5. We're not going to need to relist -2, and then 4. because I see -2 here twice, I know that this is not a 1-to-1. So therefore, it's not 1-to-1, but it's still going to be a function because that repeat is in my range, not my domain. All right, let's knock out this last one real quick. Is it a function? Oh, this one's a fun one. Let's see. When I go ahead and I cross it, take a look at those. It's solid here and open here. That's okay. It's open here and open here. Guess what? Yes, that still is a function, but no, it's not continuous. I can't draw this from start to finish without picking up my pencil. In fact, once and twice, I need to pick up my pencil to finish drawing this graph. All right, is it 1-to-1? Not here. And guess what? Anytime I have that horizontal line, no, it's not 1-to-1. So let's talk about the story of my x's. Everything from -infinity up to, now this x is still included, but this is my only place where I don't have an x value. So -infinity up to 2. And then just after 2 on to positive infinity is what can go in and out. Now when I look at what can come out, I have everything from positive infinity. And notice these points are covered here. And then this goes on. So guess what? Anything from negative to positive infinity is going to come out. Where is my graph increasing? Go back to that story of my ant. Where is he going uphill? He's going uphill from this x value to this x value. So from -3, 1, 2, 3, up to -1, he is increasing. Where is he decreasing? Here he is. He's decreasing from -infinity up to this turnaround point here. And then guess what? He's decreasing again. He's falling down on this part of my graph too. So that's from a x value of positive decreasing union and x value of +2 onto positive infinity. Now this is the first time we've had him be constant. See this horizontal line here? Whenever he's constant, that's when I have no change. So from -1 to +2 is where he's constant. And what is the y-intercept? 1, 2, 3, 4. If I go over 0, I come up 4. What is that y-intercept? It's going to be 4. All right, good job.